We are coming into our session number 10. We've been doing this for a little bit already. And we are going to be looking at classes today. So, with classes, we're looking at, um, uh, you know, a lot of folks are coming from OOD background, and so with classes, we're looking at our good old polymorphism and variety of capabilities that we come to expect of object-oriented design. Python does have full support for object-oriented design. You have your polymorphism, you have your ability to inherit, override, and do all things of that nature. However, there is an interesting paradigm, first of all, with decorators that I have brought up in a couple of sessions prior. We see a lot of very strong aspect-oriented presence. So you get AOP programming, in your strong frameworks like, anything Flask. That would be HTTP framework. When you're looking at Celery, which is ETL framework. When you're looking at FastAPI, the other framework that I keep bringing out, even though FastAPI leverages types to a great degree, it is still using AOP for defining endpoints and things like that. And so object-oriented design is strongly, is a strong presence in Python, and you do have capabilities like abstract classes and mandating certain functions to be overridden. However, with all the other capabilities, including duck typing in Python, you do not truly need to have objects in most of the instances. It is just another tool in the toolbox, and that's kind of where Python comes in an interesting way. And while it gives you capability of OOD, you have a lot of interesting solutions that kind of go beyond that and do not truly require object-oriented design. So let's take a look at, kind of restart our usual conversation. So it's time to switch over to our view of the screen and jump through a few things real quick. So I wanted to bring up, today my channel. So if you just look up Ilya Gottfried on YouTube, this is where all these videos are going. So we can, you can take a look at that at any point. As you know, we're running off of ilyagottfried.github.io Python Learn Marathon. That's the link I usually drop in the description, and all these recordings are going onto YouTube. You can Twitch stream me from here. This is kind of meta. If you're already Twitch streaming me, you already know that. So again, starting up, if you're just joining us, starting up this session, all you need to do is go to run on Replit, click that button and start, and that will start you in this project over here within Replit IDE. It will launch everything, pull it from Git, and get you here. Just to recap, so for us to actually run our test file that we're going to be executing today, we're going to be pushing play button again. We're back in that mode. However, to ensure that play button actually runs the proper file, we're going to need to go to that replit, and we're going to need to change it to classes.py, right? So that's going to be the file we're going to be operating in today. So again, going to that replit file on the left side and type in classes.py to get us going. So I have modified in preparation for today's session, I have modified it from the description that you have in the repo. So if you don't mind kind of paying attention to what's going to be happening on the screen more so than what you see in front of you, we're going to be going through an exercise close to what is in there, but I kind of last second refine it just to make sure I cover things in a proper fashion. We're gonna spend time today just understanding how to create a class in Python and how to put together various components of a class, and we're gonna do it in a practical manner to begin with. I'll talk a little bit about my pet peeve on the way classes are taught in object-oriented design. You usually start with your animal, dog, cat ordeal. I kind of don't like that because as soon as we actually start using objects in practice, we end up building capabilities and not necessarily these data transfer objects that we create data transfer objects that carry relevant data for a particular entity, but we don't override them or inherit them or anything like that. We just they're dumb objects that we kick around. And then when we have objects that carry any kind of wisdom, they are usually capability classes and not not specifically objects. So that analogy kind of works, but I really would like to see classes as a grouping of capabilities as opposed to a specific object analogous to an object in the real world, right? So for what it's worth. So what we're going to do, we're going to build a game, right? So our Rochambeau, rock, paper, scissors, and we're going to kind of play in that domain today. So what we're going to do is we're going to just build it out structurally one by one, and then we're going to write a little bit of code to actually trigger various functionality and see how it plays out, see how we annotate it, and stuff like that. As far as polymorphism and inheritance and all that stuff, I would reserve that for a separate session. It's just this is kind of just identifying parts and pieces of this is going to be enough of an exercise to cover. So let's build a game object that can count plays, validate inputs, and prompt users, right? So we're gonna start off kind of in a very basic, slow manner, and extrapolate from there. So the first thing that we're going to do, we are going to just create a class, and we're gonna call it game. And so if we do that, hit new line, obviously we're tabbed in and type in pass, we have a definition of a class in Python. So at this point, if I just hit run here and we hit Python classes, right, it ran, it was fine. So nothing came of it as expected, but it worked. So the next thing we can do here, we can just explore what this class is. So let's do this. Let's do Python. Let's go in Python on the right side and hit enter. And then we're gonna do from classes import game. Okay, so we just did that. So what that did is that specific class that we just defined here, we just imported it into our Python REPL. So if we do, if we type in game, let's see, game proper casing. So if we do type in game, it's just going to give us classes game. If we want to create an instance of that, we're going to, let's call it lowercase game equals game open close parenthesis. So, and if we type in game, it's going to come back classes game object, right? So this is kind of very straightforward. So you define class as with just a keyword class, and it already creates a class for all intents and purposes in Python that is available, and then you can import it, you can create an instance of it. A constructor is already provided for you. That is a default constructor, no parameters intrinsic to an instance of a class, and then you can create a game object and you can produce it here and take a look at its contents. Let's move on from that. The first thing that we're going to look at, we are going to initialize empty result set and score. So we're not going to do empty result set and score. All we're going to do, we're going to initialize with a number of moves or number of plays. A number of plays. So let's initialize with number of plays. What in the world does that mean? So when we're looking at number of plays, we want to put that in each time we create an instance of a game, right? So that's a perfect opportunity to create a constructor and make it happen for us, right? So the way we declare a constructor in Python, you might recall dunderInit.py as a file that we were adding into folders to create packages, right? It's an older concept, but whatever. It's a concept for creating packages. So Python has dunderInit for classes as well. And so the way you define a constructor in Python is def, so it's a function, right? DunderInit, dunder. So the next interesting thing that happens here, so let's put, sorry, why did I put semicolon? It's colon, right? And put in pass. So let's run that. Sorry, we need to go on the right and exit, right? Because we're in Python interpreter and we no longer want to be there. Okay, so we have class game, def dunderInit, open close parenthesis pass. So let's run that, and it comes through fine. However, if we want this dunderInit to actually be a constructor for instance of a class, we need to do the following. So let's do this. In order to actually experiment with this, what we want to do, we want to instantiate an instance of a class and see what comes out of that. Because right now it's just we went through definition, everything was fine. So we're gonna go if underscore name equals double quotes underscore name double underscore, right? So all these are double underscores. Then we're going to say game equals game, open close parenthesis. So we're going to go through and we're going to define, we're going to call the constructor we created, right? So let's hit run right now. And double equals, because it is a comparison, not a assignment. And so that comes through fine as well. So it's, yeah, I guess it's not going to error out on this because I was trying to demonstrate the convention, but it is refusing to error out on this specific definition. So let's get back to the fact that how do we create a constructor for an actual instance of game? So the way we do that is we pass in a positional argument, which needs to be a first argument that we would call self. This is a Python convention for passing in an instance of self to a function. So as you probably well aware, in your C, C#, Java, you do not have to pass this explicitly into your class constructors. It is assumed, and you can always leverage it internally. With Python, you do have to explicitly pass self into various class level functions. Sorry, instance level functions do have to get self as a parameter in order to create instance level variables. So now let's do let's create our number of moves variable within that. So we're gonna go self dot underscore number of moves, right? So the convention is really the same. We are creating a private variable with underscore, and we're going to assign it. Let's pass in number of moves, and let's assign number of moves here, right? So so now we have created something. If we run it, it keeps being fine with this. I don't understand what I'm doing wrong. Number of plays, colon, self number of plays, number of plays, somehow class game equal game is not, because if name equal main, oh, that is such a goofy mistake. My apologies. Okay, So if name equal main, now we're going to actually get our errors because it's executing against this thing. It was never executing that line. Okay, so now we have, it's like, hey, missing one required positional argument, number of moves, right? So if we go back, sorry, let's go back to this. Let's, never mind. Let's just keep it this way. Okay, so we have, we passed the number of moves, right? We're expecting number of moves here, so we're actually running this line. We're calling the dunder init. So in definition, it was perfectly fine, but when we called it, it required specific values. So let's initialize it with 5, right? It's nothing particularly special. Let's run that. Again, we get no output, but at least we are satisfied with the fact that game initialized with 5 results in this value being assigned. So the interesting thing here with underscore value, we honestly can do this. We can do print game dot underscore number of moves, right? So the private variable is not truly private. So that being said, it is again going to be warning level statement. So if you're going to run Python linters, if you're going to be looking at this code in an IDE that actually tracks these things, it is going to highlight the fact that you're getting direct access to a variable that's intended to be private. So various tools are going to make you aware of it, and you could set linter warnings to be errors to prevent you from actually doing that. But the language itself does not truly block you from accessing private member variables. So it is a lot of things built in Python are honor based, and there's a convention. Try to follow the convention, and there are ways to enforce it, but ways to enforce it are optional. Okay, so let's go back to kind of starting our game, right? So the first thing that we're going to do here, we are going to add a static method. So what we want to do, the first thing in the game, we want to prompt a user telling them about the game that they're about to play. So let's create that function here. So, notice indentation, right? We are 1 over from class. So we're going to go define prompt open close parenthesis. So we're going to do the following thing. We're going to go above this method, right above it, and write add static method. So this ends up being interesting. With static method, you do not have to pass in anything, because static method is not even applying really to a class, let alone the instance, right? Static method, really kind of the purpose of static method oftentimes is you want to group certain functionality with the rest of the class, but there isn't anything of that class, of the instance that is being passed into that. It is just kind of grouped with this rest of the stuff logically, and so you're able to create static methods. And interestingly enough, IDEs would actually recommend you to convert certain methods to either class methods or static methods based on what they observe the functionality inside the class being. And so what we're going to do, we're just going to print let's play Rochambeau. I think that's the way it's spelled, close enough. Let's go with exclamation point because it's very exciting. And that's all it's going to do. So to demonstrate the fact that the prompt shows up, let's dump line 25 here. I no longer care for that. And then we are going to call static method directly. So we're going to call game class dot prompt and just run that. So what's happening is we are calling, there is a prompt function that is a static method within scope of a class. So remember, this is not a class method. This is a static method, right? So next thing we're going to look at, we are going to build a method to fetch user input. So the way we're going to do it, we're going to declare another static method, right? Because we're basically providing another utility to fetch user input and nothing else really. So what we're going to do, we're going to go add static method. We're going to define prompt. No, I'm sorry, not prompt. User move. User move. And we're not going to pass anything in. What we're going to return, we're going to call function input, which is we don't need any imports for it. It's a Python built-in function. So we're going to call input, and we are going to type in make your move. And we need to make sure that double quotes show up in the right spot, because otherwise it's going to be crazy. And then we are going to, so we're returning the value that comes back from that. Double quotes are going to drive me nuts today. And so what we're going to do, we're going to say, let's go game.user move. Right, so we really have nothing particular happening here aside of, so let me just zoom in real quick so you guys can catch up. So we have our game prompt, we have game user move, and all that does, it fetches input from user and returns that, right? So we're going to run that here. Let's hit run button, make you move. I'm going to type in test. It's going to return nothing, right? So that's good. So the next thing we're going to do, we're just going to fetch that user move out of it. User move, we're going to grab that out of it as a variable, and we're going to print f user move, and we're going to type in user move. So in retrospect, that would probably be repetitive. Let's run that real quick and put it out there. It does the same thing. Make you move, we're on test. User move is test, so that's great. So let's grab that line 31. Grab it, maybe, yeah, let's grab it from here. Let's drop it in here, and let's go above, type in user move equals take an input from here, just so we wrap that, you know, prompt that this is what user did. Okay, and we're gonna do that here, and then we're gonna return user move. Okay, so now we wrapped our output, like, hey, user move was this, just to see that we registered it. Let's run this thing again. We're gonna type in test, hit enter, it's all great. Okay, so that is running for us. So the next thing that we want to do, we want to build a method to validate user move, right? So now we're kind of getting into the game specific domain, right? And so we're like, really, when we're spinning up an instance of the game is the one that should be checking what valid user inputs should be present. So what we're gonna do, we are going to set up our favorite choices variable with a list of choices, right? What we're going to do, that we're gonna make it a class level variable, and I'm gonna show you the difference between instance level variables and class level variables. So defining class level variable is going to be choices equals to rock, paper, and scissors. So we got our rock, paper, scissors as our choices. So what's happening here? When we declare a variable and initialize it within class at the same level as our defined functions here, we have just created a class level variable. So we do not need to create an instance of a class to get those values. If we go in here again, Python, and we're going to from classes import game, right? When we do game dot choices, we're gonna get our list, right? So it's class level variable. We did not need to create an instance of a game to actually see them. Let's go exit. So the next thing we're going to do, we're going to create a validate user input call, and it's going to be, we're going to pass an user move into that, and we're going to get back whether that move is correct move or not. So let's do that. We're going to create a class method. So this time we're not creating a static method, we're creating a class method. So the interesting thing with class method, it is validate user input, validate user input. So when we define user input in a class level variable, we're gonna pass in CLS as a parameter. So these are convention words that you would use for either class or instance, whether it's self or CLS. But I believe any variable, it just needs to be positionally first variable that is going to be taking in either a class or an instance, right? So we declare there's no u, just validate user input. So the next thing we're going to do, we're going to return, let's do the very basic one. So we're going to return, so we pass in user move, and we're going to return user move in CLS dot choices. Right, so we have choices class level variables here. We pass CLS in here in class method, and we're going to check whether user move is in CLS choices. So let's do this. Let's print f string. This is a valid move, and then we are going to pass game, right? So it is still class level, but it's a class function, it's not a static function. So we're gonna go game validate user move, and we're gonna pass in user move, and we're gonna get a response. So now I'll let you guys finish typing. Let's run it just to make sure that I didn't type in nonsense. So we have validation for user move, make your move. So we're gonna do test. Please work. All right, that's close enough. Hit enter. Something broke. I cannot spell validate user input. User input, not move. Validate user input. All right, so now we have validate user input. We're gonna run it. We're gonna type in test, and this is a valid move false. Obviously, if we run it again and we say rock, this is valid move true, right? Nothing particularly unexpected here. So what we're going to do now is let's dress it up a little bit and just provide provide a few prompts of what is actually expected of user, just to dress this function up a little bit. So what we're going to do, instead of return user in choices, user move in choices, sorry, we're going to go and we're going to say, if not user move in CLS choices, we are going to say print f colon. Yeah, it's doing duplicate of colon on the second turn. I don't know why it's doing that. And then we're gonna say incorrect move. We're gonna put in user move. And then we're gonna do print f, let's do our crazy double quotes, expected, and we're going to print out the choices that we have simply by just dumping the cls dot choices, dumping out cls dot choices, and then return false, and then hit enter and just step one back. Let me zoom in so you guys can see. It's not terribly complex, but it is what it is. Return true, right? So if move is not in one of them, we return false and we prompt saying this is what you should have done, otherwise we return true. So kind of nice little function doing what it needs to be doing. So let's run that. Make your move test. It's gonna say user move test and correct move expected rock paper scissors, and then this is a valid move false, right? And then otherwise, I mean obvious, but let's test it anyways. Rock because it's shortest. User move rock. This is a valid move true. Cool. So we got that. It's pretty. It's working. So next thing we're going to do. So I'm kind of building this class out, and then we're going to fill out the game logic in our name equal under main, just to give you guys a sense of kind of how do we call and structure various parts and pieces of class. So let's take a look at creating a play method. And so the play method is actually going to perform the game logic and tie it all together for us, including performing PC move. So let's create a instance level variable. So the reason we're creating an instance level function, the reason we want to create that is we are going to count down the number of moves as we go through each call, thus exhausting number of moves we should be making and then exiting at some point. And so what we're going to do here, we're going to define play, and remember we're passing in self as the first parameter, and we're passing in user move again as a second parameter. Yeah, I was trying to kind of break down functionality so that it's not questionable from kind of choices of organizational choices of code the best I could, right? It's like all of these examples are kind of forced in any way, but trying to kind of just break down the functionality here in a nice way. So first thing we're gonna do, we're gonna make an NPC move. So our NPC move, as you remember, I zoomed in, now I need to zoom out again. We're going to be leveraging function choice from random libraries. So let's go somewhere to the top here before comments, or let's go line 7 before the module comment, and we're going to from random import choice, right? So we did from random import choice on top here. Okay, and then we're going to go back to our play, and we are going to do the following. We're going to say move NPC is equal choice open parenthesis. So class level variables are also present on an instance of any given class. So we can actually go and say self.choice, and we're gonna get access to those choices actually, because it's plural, right? So choices. So self.choices is actually going to give us access to this variable, even though it's a class level variable and not an instance level variable. Kind of makes sense, but it's still, within this context, that's how this works out. So we're going to print and we're gonna say PC move NPC, close that. I'm going to just short circuit the game logic by saying print who won question mark. Right, just to put that out there. And then the next thing we're going to do, we're going to go to our core interaction with our variables. So we're going to go self dot underscore number underscore of underscore moves, right? So that's our instance level variable, right? So instance level variable, literally when we call dunder init and we set self dot variable name, this is where instance level variable gets created. As you see, it is not declared anywhere else. It is just created when init is called. And so all the class level functions would be called on an instance of a class. So at that point, that variable has been declared and instantiated, as part of the instance, and therefore, it is, it makes sense to have that, available in this case, and everything works out, even though you don't declare it anywhere aside from creating it in the dunder init, in the constructor. Okay, so self number of moves minus equals 1, so we're going to drop it by 1 with whatever we initialized it, and then we're going to return. So we're trying to determine if we should continue playing. So we're going to go return underscore number of moves is greater than or equal to 0. Just one of those setups, and let's do the following. Let's put in a loop that would make user enter a valid input, and until they do, we're gonna keep on looping and requesting user move. So we declare user move equal to game.userMove, right? And so we are going to then, instead of printing this thing, we are going to run if statement, if not, not if, we're going to run while statement, right? So while not game validate user input user move, let's clean this thing up here. So while not game validate user input user move, we are going to continue saying user move is equal to game dot user move, right? So we're going to continue validating and running it in circles until we get it right. So if we run this right now, make move, if we run and test, it's going to say user move test and correct move test, expected rock, paper, scissors. If we go paper, user move paper, so it's fine, it let it through. And so the next thing we're going to look at is we are actually going to play. And so we're going to say this time play because it is an instance level function. We're going to say game lowercase, right, because that's our instance of game. Game.play. We're going to pass in user move and see what comes of it. All right, so we're going to run again. We're going to type in our test. It's going to say can't do it. We're going to say scissors. Now stop helping me. Scissors. User move scissors, PC move rock, who won? Anyways, but it actually played the game through. And so the next thing we're going to do, we are going to play through this and let this thing count down until we don't want to play another game. So what we're going to do, we're going to go at game, when we create an instance of a game, we're going to put a while loop there. No, we're going to create play another variable, play another. We're gonna set it to true, and then we're gonna go while play underscore another. We're gonna continue. So let's take line 52 through line 55. Let me zoom everything in so you guys can see it better. So we're gonna take line 52 through line 55. We're gonna tab all of them in. So now we have this indented, and what we're going to do when we run a gameplay, we are going to say play another equals gameplay. And so basically each time we're going to play the game, we deduct by 1 until we run into 0, and then we stop the while loop and quit. So this time we're just going to run this, rock, 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 rock. It's supposed to be 5. Okay, I can't count, so it's 1, 2, 3, 4, 5, 6. Because I start and then I subtract after the game is played, so we get what we get. So it should be greater than 0, not greater or equal to. Okay. Off by 1 errors. Okay, so we are now looking at this play method that we created, so that's all great, right? It would be kind of useful to see how many iterations we have left to play. So next what we're going to do, we're going to look into proper way of accessing private variables, and that is creating properties. So property getter. We'll create a property setter just to, we're not going to use it, just to show you what's possible and how to do this. But we start off with property getter. So the way we would do property getter is we are, guess what, putting a decorator on this thing called add property. So we're creating add property, and then we can define that property def remaining moves, or remaining moves is fine. So it is going to be, this is going to be the way you define a class property. So it is going to be remaining moves, and you're going to pass self into that. And at this point, you will return self dot underscore numbers, number of moves, number of moves. Okay, so we created remaining moves as a property, number of moves, right? And so the variance between the property and the function, as you know, you can call it as if it is a variable. And so you can do, at this point, you can do print f remaining moves is going to be, it's an instance level, so it's game lowercase g game because it's an instance, remaining underscore moves. Let's run that and see what it does. Test is gonna not, rock is gonna yes, and remaining moves is 4. Again rock, and so forth, right? So that's, we can Control C to interrupt this whole thing, but as you see, that would be a way to pull property in. So if we were to try to do something as silly as game dot remaining moves equal to 100 and run this, it's going to make us go through rock and then go to the next, and then it's going to throw up because attribute cannot attribute error cannot set attribute. So it does truly create a read only value for us. Well, so if we want to set it, this would be kind of ridiculous, but I'm going to set it to 1 just to shorten our suffering. But if we want to set it, we need to create a setter. And setter is created in kind of an interesting way. So you're going to go at, and you're going to use the name of the property. So it's going to be remaining underscore moves dot set. And this is how you're going to declare the setter, and you can define. I wonder if you name it the same way. That should work just fine. And so you would pass in self and you would pass in value here. And then internally you can do self dot number of moves equal to value. So let's see, this ends up being really, really weird. Let's do this. Let's start off with this just to make it less confusing. So now we have a setter for it. And so now if we run this line, if we run, it's not set, it's setter, actually. Okay, so now we have it. So let's run this. So now we're gonna, let's make a move. It's gonna be rock, hit enter. We cannot set attribute. Okay, so let's name it the same way. Sorry, I got a bit off track here with doing it the right way. So let's do rock again. Okay, so rock again. Okay, so we're calling remaining moves as a set, but it's not setting it because I just did something silly here. So we need to, let's stop this, and let's actually number of moves. Okay, this is getting a bit dizzying, sorry. So let's run this again. Let's do rock. Let's do rock again, and that should exit. Okay, so everything has to align normally, otherwise it just kind of played through. So what happened the first time around, right, we initialized with 5 in here, as expected. Then we read our property in to show how many moves we had. Then we forced our property with a setter that we generated to look at, to set the remaining moves to 1, right? So we short-circuited it down to 1, and then obviously the next move that we made, it actually just set it to 1 and exited. So yeah, so that's kind of the basics of creating a class and creating various elements and parameters. So like if we just look really quickly through, so we have class game, that would be the way to declare a class. Then we have we declare the class level variable choices, rock, paper, scissors, because it kind of belongs to the notion of the game, so it belongs to the class level. Then we went into def underneath, which is our constructor. This is the way we define constructor in Python. We created a class level variable on the spot here. Essentially, this would be the first time an instance gets created. This variable gets declared on the class, and we assign it to whatever value we passed in. Then we create a static method that is really just belongs in this grouping but doesn't really operate on anything within the context of a class. Then we have user move, another static method which operates on no variables but just does some processing within the context. We have a class method which just validates using the choices which are class level variables. So we pass .cls into it for class method. That's an expectation that the first variable is going to be class itself. So it's not an instance of a class, it's a class itself, right? And then play is an instance level function. That one doesn't have any decorators, and that is the default construct for defining functions under class is an instance level function, so it does expect self in there. In fact, one thing that I kind of screwed up in the beginning to show is that if you don't pass self, it says I expect one variable to be in the beginning of definition of the class, of definition of the constructor, and you don't have it, what's happening. And so so that's that. And then we looked at the properties. So property we declare with property decorator for setters. That setter is a default for getter. Sorry, getter is a default, right? And if you don't declare setter, it actually masks the internal variable and doesn't let you just set it. And then to declare it, to declare the setter, you need to actually use the name of the property, and you need to name the setter the same way as name of the property, and you would pass in self and the value into it. Make sure that you spell the internal variable right. And the other ironic thing that we learned is that you can actually access, private variables, but linters and things like that will actually react to variables that are named with an underscore and would tell you that, like, hey, you're trying to access private variable. So that's kind of the run through of this. So the next thing, we have a little bit of time left. We're going to actually examine a few interesting elements that you have available for a class and for an instance, and that we can explore in Python looking at all this stuff, right? So let's go to command line and run Python. And what we're going to do, our import, from classes, import game. So we are going to call a function dir that actually breaks down what is available in an instance or a class or what have you. So if we do dir on game, we are looking at what functionality is available at class type, right? So we are getting here that you can get game dunder class and dunder dict, dunder dir, and so on and so forth. So let's first type in game and see what it actually is. So it's class that is of classes game, right? And we can do game.dunder class. Let's see what that has. So game itself is of class type, right? So declaration of class game is an instance of class type. So that's kind of, so all the dir game that you see here, all these functions and parameters are available on class type. The other interesting thing that you see here when we did dir game is that you see our the elements that we have on this class. So we have choices, we have play, we have prompt, we have remaining moves, user move, validate user input. So all these things are available here, and remaining moves is kind of the single entity that we see here, right? So we can examine it, and so further we can do game dunder dict. So all this, as you remember, all these dunder functions, they are Python level built-in functions that allow you to work with variety of things and variety of elements. So interesting thing here, one of the things to kind of grab onto, you have dunder doc, right? Dunder doc is none. We don't have anything written up for classes documentation. Let's mess with that tiny bit just real quick. So we'll go into here, and right below class definition, we put in multi-line string. Remember, our multi-line string could be this is a doc string for game class. So we have that. So we are going to So if I run import again, I believe import is not going to happen because Python is smart about imports and it does imports only once. So we're going to need to exit. Let's exit open close parenthesis. And we are going to run Python again. Let's do our from classes import game. And so let's go in here and let's take a look at our game dunder dict. So let's see, please work, please work. We were looking at doc. There you go. So our doc right now this is a doc string for game class. So when we placed a multi-line string right below our class, so we can actually go and do game dunder doc, and we are going to see doc string for the class. So this is Python convention for documenting your code, and so in reality there are a variety of frameworks that will pull out the strings declared within, string literal is declared within module, string literal is declared, within function, declared within class that will be associated with that particular entity. And so there are a variety of frameworks that are actually building out documentation based on this doc strings being present in a particular conventional way within the system. So the next thing, we're gonna take a real quick look. We have a few minutes. We're gonna take a really quick look at instance of the game. So let's make game lowercase equal game uppercase, which is a class. And let's put in 5. Let's run that, and then let's do dict on game itself and see, not dict, I'm sorry, dir. Dir is a function. Dir is a function. So we have all these elements that we have, and as expected, we have so we have number of moves, right? So we did not have number of moves in here because this is an instance level variable, not class level variable. So now we have underscore number of moves available in class instance, and we can do so if we do game dot dunder dict, that's a dictionary that represents our class. So all it comes back with is number of moves is 5. So it actually breaks down with instance of the class. It breaks down and gives us the parameters of the class and what they're instantiated to, specifically instance level variables. And so we have that. We have, as you see here, we have variety of capabilities. We have, so we can build comparators, right? We can do greater than, less than, equal to. We can leverage that in comparisons for testing if we wanted to. We can do, so dunder str. So if we do print, game right now, write an instance of the game, we get this classes.game object at blah. If we were to define dunder str function, we could print out, this is the game instance with number of moves equal to 5. And so when we would do print game, it would actually call dunder str instead of presenting this to us, which is default output. So that's kind of, we can override that. Failed to connect, yay. So we can override that to present our classes in a certain way if we want to have control over inputs. And so there are a lot of, you can do size of, you can do comparisons, you can do hash if you want to use it as key dictionary, as dictionary key and things like that. So if you actually override hash, it would work. So yeah, that's kind of the core of just looking at the class and the structure, and we're kind of right on the time here. So I'm going to complete this transaction here and complete this video, and thank you, and we will see you guys next time.